Hello everyone, this is another extra video that show you the proof of the Euler formula, which is the exponential of theta times j equal to cosine theta plus sine theta j. And before we try to prove the Euler formula, let's go over some Maclaurin series that you have seen in Calculus 2 or Calculus BC if you're a high school student. The Maclaurin series of exponential theta gonna equal to the sum of theta power n over n factorial from n equal to 0 until infinity, and this is gonna be the expansion version, which is 1 plus theta squared over 2 factorial, and you can try it on your own. And this is gonna be the Maclaurin series of cosine and sine. They look kind of similar, but only one small difference. For cosine, the power and the factorial gonna be the even number, which is 2n. And you can see in the expansion version, they are always even number 2, 4, and 6. But for sine, the power and the factorial is always odd number. And you can see 3, 5, 7, 3, 5, 7, they all odd number. Now let's try to apply the Maclaurin series of exponential with the power of theta times j. So exponential theta times j. And now we try to expand it using the series. So we have 1 plus j times theta plus j times theta squared over 2 factorial plus j times theta power 3 over 3 factorial and plus j theta power 4 over 4 factorial and j theta power 5 over 5 factorial and plus etc. So now let's try to simplify those terms in the end. So 1 you copy down, j theta you copy down, and so if you square the imaginary number, so j is actually equal to square root -1, but if you square it, then your answer is gonna be -1. Therefore you're gonna have negative theta squared over 2 factorial. So now let's try to simplify this term right here. So we're gonna have j power 3. So j power 3. So j power 3 you can expand it into j squared times j. And we know from above that j squared equal to -1, so it's gonna be negative j. Therefore, from here you're gonna simplify into negative j theta power 3 over 3 factorial. And since we have the negative right here, so let's replace the plus sign with the negative sign. So now let's continue with the fourth term. So this time we're gonna have j power 4. So let's write right here j power 4. So j power 4 you can expand it to j power 2 times j power 2, and j power 2 equal to -1. So -1 times -1 you're gonna get 1. Therefore for this fourth term you're gonna have theta power 4 over 4 factorial. And if you keep doing, you're gonna have j times theta power 5 over 5 factorial and even more. So now let's try to factor out the j, because you can see this term right here you have the j, this term right here you have the j, and this term right here you have the j, right? So now let's factor it out. You're gonna copy 1 down, and any term that doesn't have the j, which is theta power 2, theta power 4, we're gonna move them to the front. So minus theta squared over 2 factorial plus 4 factorial. And do you guys notice the pattern? Any theta term that have the j in front of it, like j theta third, j theta fifth, the power is always an odd number, right? So that means any term that have the j in front of it always have the power of odd number. You can see right here it's actually 1, here's 3, and here 5. And also any term that doesn't have the j, like this one doesn't have the j, the power is always even, right? So therefore you can guess like, oh, 1 minus theta power 2 over 2 factorial plus theta 4 factorial. So any other term that doesn't have the j always have an even number. And also if you try to find the sixth term by yourself, so let's say j power 6 over 6 factorial, then your answer is going to be negative theta power 6 over 6 factorial. And if you try power of 8, then you're gonna have theta 8 over 8 factorial. Yeah, you can try to do it by yourself. So yeah, the more you can do, you can see like it's oscillated between minus and plus, minus and plus, and also the power is always even if it doesn't have the j in front of it, and everything else has the j. So now let's group all the j. So now we factor out all the j, right? And from our pattern we see that any theta that have the j always odd number. So theta in here, so you have theta 3 factorial. In here we have plus theta 5 over 5 factorial. And if you do more by yourself, like let's say 7, 9, then you're gonna have theta 7 over 7 factorial, and yeah, even more. So now, do you notice something? Any term right here from 1 until 8 and then other even number is actually resemble the cosine series. You can see 1 minus theta square plus theta 4 minus theta 6. You can see right here, those things right here is actually the cosine. And everything else that have the j in front of it, like this group right here, is actually resemble the sine. You can see theta minus theta third plus theta fifth minus theta 7, everything right here resemble the sine. Therefore you're gonna have cosine theta plus j sine theta. And this is the proof of the Euler formula.